Ayan, good afternoon. Good afternoon to everybody. Ayan. Let me start the lecture discussion. For this afternoon, we will officially begin another chapter of topic. So finally, we will begin discussing isomerism. Supposedly, yung isomerism na topic class is part of midterm. So remnants din siya ng midterms. But let's try to catch up no atong mga topics that were that supposedly part ng midterm. Sige lang, kay ato lang ni siyang apasun. Sige. So I repeat, for this afternoon, we will be discussing all about isomerism. Now, ang isomerism class, this is one of the properties of carbon. Okay? One of the properties siya ng carbon atom, carbon elements. Now, it is very important to know, identify the different properties ng carbon atoms class because you all know na ang main focus, 'di ba, ng subject organic chemistry are organic compounds, and yung pinaka-distinguishing character ng mga organic compounds is that they contain a carbon element. So importante din na aralin natin yung properties ng carbon atom. Now there are already properties ng carbon atom that we have discussed in our previous na mga discussions. Halimbawa, yung stability. We have mentioned na ang carbon as an atom, parte ng structure, this is a stable atom. Okay, it attains stability. Particularly, it is highly stable, wherein yung stability niya is relative to the octet rule. Diba? Pag sinabing octet rule, it attains 8 surrounding valence electron. Okay, in a structure. Ang carbon atom in any structure, for it to be stable, it should attain 8 surrounding valence electron. And yung 8 valence electron na yan is being shared by 4 covalent bonds. Okay? So, pwede sa isang structure, ang carbon atom may have 4 single bonds. Okay? 4 single bonds, covalent bonds. Pwede din naman ang carbon atom may be surrounded by 2 pairs of double bonds. So that is also equivalent to 4 covalent bonds. Diba? Bilangin nyo lang yung mga bond lines. Diba? 4 yan na covalent bonds. Pwede din yung carbon atom may carry 1 triple bond, isang single bond. Alright? Or another condition din ng carbon atom, pwede siyang mag-occur wherein meron siyang dalawang single bond, isang double bond, okay, surrounding it. So all in all, 4 covalent bonds pa rin what surrounds that carbon atom in any structure. So yan yung una, stability. And you have already known this, no? Yung stability ng carbon. Next, this is also another property of carbon atom that was also discussed. Yung hybridization, di ba? Pag sinabing hybridization, this is mixing of 2 or more atomic orbitals para makabuo tayo ng another new set of equivalent orbitals, or yun na yung tinatawag na hybrid orbitals. And we have 5 different, di ba? 5 different hybridizations, okay, ng element. But for the carbon atom, class listen, for the carbon atom, ang hybridization niya, okay, it could only exhibit 3 hybridization kasi meron lang siyang 4 na covalent bonds. So tatlo lang yung posible niyang observable or ma-exhibit na hybridization characteristic. So we have the sp, sp2 hanggang sp3. So how do we identify na yung carbon atom na yan in a structure is in sp3 hybridized, sp2 hybridized, or sp hybridized? Now, class listen, kapag ang carbon atom in a structure is being surrounded solely ng mga single bonds, I repeat, kapag ang carbon atom in a structure, it is being surrounded only by single bonds. Okay? Ibig sabihin, yung carbon atom na yan is in sp3 hybridization or naka-sp3 hybridized yung carbon na yan. Okay? Let me ask you nga, if naka-sp3 hybridized yung central atom, ano yung molecular geometry or molecular orientation ng central atom na yan? Is it linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, whatsoever? Sige nga. This is just an application of what you have learned sa previous natin na discussion. Sige nga, kapag may apat na electron groups surrounding a central atom, sp3 hybridized, what is the orientation of that central atom? Okay, very good. Naka-tetrahedral yung orientation. Very good. Kasi 'di ba yung hybridization ng isang atom, it is in relation or relative lang din sa kanyang molecular geometry. Okay? Sige, next. Kapag naman ang carbon element in a structure, a carbon element in a structure, they carry one double bond. If they carry one double bond, then that carbon atom is in its sp2 hybridized. Okay, naka-sp2 hybridized yung carbon atom if it carries one double bond. So kung titingnan mo per carbon, carbon on the left side, carbon on the right side, meron silang tig-iisang double bond. No? They carry double bond. Kumbaga ganito yung orientation nila. Itong ayan, yung binox ko. Okay, ito yung naka-box na kulay red sa taas. 'Di ba? Each carbon atom ganito yung orientation nila. They have one double bond. So in that case, naka-sp2 hybridized. Okay, and you'll observe na meron siyang tatlong electron groups. Tatlong electron groups, mga bonding groups. Therefore, yung orientation niya this time is naka-trigonal planar. So itong each carbon na to, naka-trigonal planar yung orientation. 'Di ba? Kapag sp2 hybridized, trigonal planar. Okay? Now, kapag naman may triple bond na, presence of triple bond for that carbon atom in any structure, ang carbon atom carries already a triple bond, then that is in linear orientation. So sp hybridized na yung carbon atom. Okay, sp hybridized linear orientation. Another another orientation or structural feature, yung another structural feature ng carbon atom for it to be considered sp hybridized is ito, yung being labeled sa gitna. Ayan, kapag ang carbon atom meron siyang dalawang double bonds na. Kapag it has two double bonds surrounding it, if it carries two double bonds, then that is in sp hybridized as well. Okay, naka-sp hybridized as well. Kasi if you will observe, equivalent to two surrounding electron groups din yan, naka-linear din to. Itong carbon, yung nasa gitna lang ha, naka-linear orientation din siya. So same with this carbon atoms, naka-linear orientation. Kapag linear orientation kasi sp, hybridized yung mismong central atom. Okay, so yan yung tandaan nyo ng mga posibleng hybridization ng carbon atoms in a structure. sp, sp2, sp3. Now let me ask you, ayan, lumabas na yung answer. So, okay, never mind. So, itong yung mga nasa gilid, ito. Itong being underlined na carbon atom, these are just synonymous to the second one. Okay? Diba kung titingnan nyo, yung structural features ng carbon na to, they carry one double bond. So, sabi ko kanina, kapag one double bond, sp2 hybridized yan. Pero kapag dalawang double bonds na attached to that central atom, then that is already sp. Okay, sisulat ko ha para naamoy summary sa inyong notes. Ayan. So, class kapag, na-stop ko yung sharing, no? For a while. So, let me write a summary note para madali nyo na lang ma-identify yung hybridization ng carbon atom. So, kapag all single bonds surrounding a carbon atom, then that is sp3. Kapag merong isang double bond, okay, surrounding a carbon atom, then that is sp2. Kapag dalawang double bonds, these are bonds, double bonds, okay, or merong isang triple bond, then this time, this is sp, hybridized. Okay? So yan lang yung palatandaan nyo, okay, to identify, or much more easier ba yung identification yun ng hybridization ng carbon atom in a structure. Siyempre, per carbon atom man mo mag-identify, hindi yung whole structure, di ba? Per carbon atom in that structure, you will be identifying its hybridization. So kung alam mo magbilang ng bonds, single bonds, double bonds, triple bonds, and you can answer what is the hybridization of that central atom or carbon as a central atom. Sige. So yan yung first two properties ng carbon, the stability and also hybridization. Now, the third properties of carbon, which will be the heart of our discussion for this afternoon, is the isomerism. Now, yung isomerism class, that is a phenomenon wherein yung structures, okay, or molecules, ito yung phenomenon wherein yung molecules exist, okay, in the same formula but of different structure. Okay, you have molecules, set of compounds. Parehas sila ng formula but different yung structure. Okay, so somehow you have knowledge already what are isomers, diba? So yan lang po yun. No? Kapag isomerism, ito yung phenomenon or the existence of molecules, two or more molecules having same formula, however, they differ now with the structure. Okay, so paano nagkakaiba yung structure nila? Pwedeng yung difference in the structure could be caused by the differences in the arrangement of atoms. So that could be one. I repeat ha. Yung differences in the structure, kapag may isomerism being observed, pwedeng yung difference in the structure could be caused by differences in the arrangement of atoms in space. Or pwede din naman yung differences sa structure could be caused by the differences in the arrangement of atoms in the carbon skeleton. Okay? So ito yung posibleng conditions natin bakit nagkakaiba yung structures, okay, ng mga isomers. Okay? Pwedeng nag-differ in arrangement of atoms in the carbon skeleton. So nag-differ sila sa order of bonding. Or differences sa arrangement ng atom in space. So nagkakaroon ng differences sa spatial orientation. Kaya meron tayong dalawang classes of or types of isomerism. So yun yung idadiscuss natin, okay, under isomerism. So I repeat class, meron tayong two general types of isomerism. So we have the structural, sige pagkisulat mo, structural or constitutional isomerism. And then yung isa, is the stereoisomerism. Stereoisomerism. So kapag yung isomerism, the differences in the structure is due to differences in the order of bonding, then that is classified as constitutional isomerism or structural isomerism. Kapag naman yung differences in the structure is due to the differences in spatial orientation, then that falls under stereoisomerism. Okay, so yan yung dalawang types of isomerism. And this will be the kumbaga flow, no? The diagram flow of our discussion under isomerism. So ito yung sinasabi ko na dalawang uh, types of isomerism. The structural or the constitutional, and then the stereoisomerism. For this afternoon, my goal is to finish the specific types of structural isomerism. Okay, so we have 6 specific types of structural isomerism. Yung first 3 dyan, yan yung mga pinaka-common. Commonly encountered, kumbaga. Commonly encountered structural isomerism is yung chain, positional, tsaka functional. Whereas yung last 3, remaining 3 types of structural isomerism, ito naman are rarely encountered. Okay, rarely encountered lang sila. Okay, pero i-discuss ko pa rin siya. Meron lang silang distinct properties or distinct structures kung saan sila na-observe. Okay, yung remaining 3. Then under stereoisomerism, we have the geometric, optical, and conformational. Next meeting naman natin yan i-discuss, yung under sa stereoisomerism. Alright? So ganito class, during my discussion, whole discussion sa isomerism, I will not be letting you draw structures of isomers. Ito yung dapat yung i-target or i-achieve nyo for this topic about isomerism. Dapat alamin nyo, i-master nyo how to identify if it is a structural or stereoisomerism. So just be familiar with the types of isomerism and paano kayong mag-identify. So given na yung structure or could be the name of the structure, you just have to identify if it is chain isomer, positional isomer, functional isomer ba? Okay? But in here, I will not again let you draw. Okay? Walang drawing of isomers. Purely identification of isomers lang. Okay, so yan yung i-master nyo. So yeah, let's begin with the first type of constitutional isomers or structural isomers. So una, we have chain isomerism. So how do we identify na yung mga structures na yan, chain isomerism? By the way para hindi mawala yung, hindi kayo mawala sa topic, basta isomer, same formula, but different yung structure. Dapat yan yung ma-observe natin for the whole topic ng isomerism. Same sila ng formula, different yung structure. So ano yung pagkakaiba ng structure kapag chain isomerism? Okay. Kapag chain isomerism class, listen, this commonly occurs among alkanes. So you know already what are alkanes. You have encountered many alkanes. Kapag alkanes, carbon to carbon single bond or carbon to hydrogen single bond. So class, kapag chain isomerism, this is only observable among alkanes because yung alkanes, they have that nature of branching. Okay? Yung pinaka-capable of branching are the alkanes. So yung nangyayari sa chain isomerism, yung carbon atoms are being linked to the parent chain or main chain in different ways. So halimbawa, Ayan, C4H10. Again, how we are talking here, alkanes. Kasi commonly occur man ang chain isomerism among alkanes. So meaning kapag nakakita ka ng formula dito under this slide, you would expect na condensed formula yan, general formula yan rather, general formula yan ng alkane. So, kapag C4H10, what is that alkane? What you have on your mind nga alkane kapag C4H10? Apat daw yung carbon sa isang alkane. Very good. This is butane. So that's one. That's one structure nga pwede nyong ma-obtain for C4H10 formula. Okay, so that's not a problem. Kasi 'di ba, CnH2n plus 2, yan yung general formula ng alkanes. So kung isa-substitute mo yan, so C4H10 would be an alkane. Okay, apat yung carbon, then 10 yung number of hydrogen. Okay? So this structure being presented, yan, yung una, that is the structure of a normal butane. Kumbaga, kapag sinabing normal butane, lahat ng carbon atoms are just being connected in a straight chain or straight line. Okay? Now, I have discussed an isomer of butane. Ano yung name ng isomer of butane? Isomer of butane. Ano yung pangalan? Okay, very good. It's isobutane. Naalala? So, yan yung another structure na pwede nating obtain from this general formula, C4H10. And you have that in your notes na magkaiba yung structure, 'di ba, ng isobutane sa normal nga butane or straight chain butane. Ayan. Okay, I hope klaro ha. Ako siyang i-zoom. Ayan. So you will observe here nga parehas sila ng formula. Okay? They have the same formula. How will you know nga same yung formula? You simply count the number of carbon atoms, the number of hydrogen atoms in each of this structure. O, simulan nyo sa taas. Yung una, butane, 4 yung carbon. Ilan yung hydrogen? 3, 6, 10. No? Whereas yung nasa baba na structure for isobutane, ganun din. Meron siyang 4 na carbon. Tingnan, as being underlined. 4 yung carbon, bilangin nyo lahat ng hydrogen dyan. 3, 6, 9, then yung nasa gitna. 10. Okay? So parehas sila ng formula. But kung titingnan mo yung arrangement ng atoms, different. Particularly, they differ in the order of bonding. Diba? Yung order of bonding nila magkaiba due to branching. So yan yung chain isomerism. It commonly occurs among alkanes, okay, due to branching already. Okay, so yan yung halimbawa, butane and isobutane. Okay? Another example, C5H12. So what is this alkane? Probably. Ano yung normal alkane that you could obtain from C5H12? Okay, tama. That is pentane. Okay, so ito yung structural formula ng pentane. 5 yung carbon, bilangin nyo, 5 yung carbon, then try to check the number of hydrogens. 12. Diba? 3, 6, then another 6 sa internal carbon. So 12 hydrogen. Ngayon, yung pentane, meron siyang 2 isomers. And this is one of my assignments sa inyo, ha, di ba? Last previous meetings na to sa alkyl groups. I have told you to search for the structure of isopentane and also neopentane. Okay? So ito yung mga posibleng isomers ng pentane. Kung baga, the same formula, they will have this formula C5H12, only that magkaiba na yung structure nila sa pentane. Okay? Bakit nagkaiba ngayon yung structure? Magkaiba yung branching. No? Magkaiba yung order of bonding. Now, let me ask you, what is the systematic name of isopentane? Kapag sinabing systematic name, ito yung name ng alkane following the IUPAC rules. How do you name that? What is the name of this alkane? The parent chain is butane. So you simply identify the substituent. Sige nga. Okay, very good. 2-methyl butane. Diba? This would be your carbon 1, 2, 3, and then 4. Okay? So at carbon 2, merong methyl. So 2-methyl butane is also equivalent to isopentane. Diba? So magkaiba na yung molecule, no, sa pentane. This is pentane, yung isa is already 2-methyl butane. So you will expect na kapag isomers na structure, different na yung properties, physical, chemical properties. Kasi magkaiba na yung structure. Okay? Now, for neopentane, ano naman yung other name niya or the systematic name ng neopentane? Sige, paki-type in. Neopentane. Tingnan niyo lang yung structure. This is just an alkane. Okay, so find the longest chain and then identify the substituent. So you have, the parent is a propane. So identify the substituents. You have 2 substituents at carbon 2. Sige. It's, galag na ako ang chat box. Sige class. Okay, you try to answer. Para di sad mo katulgon. Okay, very good. 2,2-dimethyl propane. Madali lang kapag alkane, no? Kapag alkane. Okay, 2,2-dimethyl propane. Okay? So you have carbon 1, 2, 3. At carbon 2, meron kang methyl. Kaya 2,2-dimethyl propane. Diba? So, all these structures, itong tatlo, itong tatlo being checked, they all have this formula, C5H12. No? C5H12. Same formula, different yung structure nila. And these are all alkanes. Diba? Kaya ang ato namang observable na structural feature sa ilahang molecule is a carbon, single bond to a carbon. So purely alkanes yan. Nagkakaroon ng differences sa structure due to branching. Sige, let's have another example. What about hexane? Kapag hexane, ilan yung hydrogen? Sige nga, you substitute CN, H2N plus 2. It's, okay. So, 14. Okay, very good. So, C6H14. So, yung hexane, normal hexane, yung idodraw ko ha is yung skeletal structure lang ha para mabilis tayo. So, you have, ayan, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 6. So, yan yung structure ng hexane, the normal hexane. Okay, straight chain, yung connection, straight lang yung connection ng carbon atoms. Now, yung hexane could have, I think, four possible isomers. Tingnan natin ha. Pwedeng, ayan, 5, 1, 2, 3, 4, 5. Then yung pang-anim na carbon, branch na. Or 1, 2, 3, 4, 5, yung branch nasa gitna. Okay? Yung pang-anim ba na carbon, isa ng branch or substituent. Pwede din, 4 lang yung carbon chain, 1, 2, 3, 4. Then, yung dalawang remaining carbon, puro branches. Or, 4 na carbon chain, yung dalawang remaining carbon, para maging 6 na carbon, okay, nasa same carbon yung attachment, okay, on the main chain. Now, if you try to check the number of carbon atoms, the number of hydrogen atoms in these drone na mga molecules, they will attain this formula, C6H14. Okay? So yan yung halimbawa ng chain isomerism. So purely it occurs among alkanes. Okay? Due to branching, di ba? Yung mga dinro ko na ng mga isomer, itong mga being checked, may mga branches na. Okay? So pwede ka maka-attain ng isomer from a straight chain alkane by simply producing branches. No? Magba-branch ka lang. Okay? Lahat yan, lahat na being checked na molecules, 6 yung carbon. So imaginary na yung mga 14 hydrogens. Okay, you can check that sa inyong independent time to study. Okay, so kindly screenshot this one, then let's proceed to the second, structural isomerism. Okay, so yan yung tandaan nyo ha, kapag chain commonly occurs among alkanes. Okay, alkanes. Sige. Next. Okay, we also have positional or position isomerism. Kapag naman position isomerism class, it occurs when functional groups or pakidagdag na lang sa inyong notes ha, or substituents are attached on different positions on a carbon atom. Okay? So you have a carbon chain pa rin, carbon chain, then may presence na ng functional group. Okay? So pwedeng may double bond, may triple bond, alcohol, okay, etc. Or may halogens. Okay? This time, nagkakaiba yung structure, okay, ng isomers because of the different positions ng functional group present. So let's, for example, okay, for this molecule, C4H8, sabi dito, it is an alkene with 1 double bond. So pwede, C4 man, so C4, 4 yung carbon, this could be butene. Tama? Kasi alkene with 1 double bond. 4 man yung carbon. So butene yung isa na pwede nating ma-obtain from that molecular formula. So that is butene. Tama? 4 yung carbon with 1 double bond. Question, nasaan yung location or position ng double bond? You give me the number, okay? Number which indicates the position of the double bond. Okay, very good. Nasa sa carbon 1. Okay? Ay, sorry. Ayan. Kasi 'di ba, kung saan mas malapit yung functional group, you start numbering there. So this would be carbon 1, 2, 3, and 4. So this is 1 butene. Sorry. Ayan. So that is 1 butene. Now another position isomer na pwede nating ma-obtain with this molecular formula is simply transferring the position of the double bond. What do you think? What is the other butene na pwede yung ma-obtain? Okay? By simply transferring the location of the double bond. Kung may 1 butene, kung i-transpose mo siya or i-transfer mo yung double bond, position ng double bond, what is the other butene molecule na pwede nyong ma-obtain aside from 1 butene? You simply transfer that 1 double bond. You could obtain 2 butene. Very good. You could you could obtain only 2 butene. Walang 3 butene. Bakit? Kapag tinransfer yung let me draw the skeletal structure ha. Kasi may sumagot na 3 butene. So if I will transfer the double bond on this terminal part, is it 3 butene or 1 butene? 3 butene or 1 butene? Very good. It's 1 butene. Kasi yung numbering ngayon, ito na yung magiging carbon 1, 2, 3, 4. So it is still 1 butene. So dalawa lang yung possible molecule, alkene molecule na pwede nating ma-obtain with this formula C4H8, 1-butene or the 2-butene. Now, you will observe na parehas sila ng functional group present. Di ba? Parehas sila ng functional group present, only that magkaiba yung position ng functional group. Magkaiba ba yung position ng double bond? Yung sa unang molecule nasa carbon 1, sa pangalawang molecule nasa carbon 2 na. So that is an example of position isomerism. So kung paga yung pangalan mismo ng type of structural isomerism is already your indicator or kung paga hint mo, okay, how to identify na position isomerism yan. Nagkakaiba sa position, okay, ng mismong functional group. Okay, magkaiba yung position ng functional group. Now, C3H7 Br, ito naman isa tong halide, okay, or haloalkane, halide or haloalkane. Okay? So you have a 3 carbon, okay, with a bromo. Okay? 3 carbon, tingnan, 3 carbon with a bromo. So pwedeng ang bromo attached on carbon 1, so this would be carbon 1, or yung bromo could be attached sa carbon 2. Okay, so dalawa yung pwede nating ma-obtain na structure from this molecular formula, C3H7Br. Imaginary dyan, 7 hydrogen. Okay, 7 hydrogen. Try natin i-check. This carbon atoms, yung mga kulay black, carbon yan. Mga terminal carbons, itong mga terminal carbons, meron itong imaginary na 3 hydrogen, tama? Kasi per carbon, 4 dapat, di ba, yung covalent bonds niya. So imaginary dyan, per terminal carbon, each 3 hydrogen ang imaginary. Then dito sa gitna, merong 1 hydrogen, imaginary. So total of 7 hydrogen. Yung imaginary hydrogen. Okay? So 1 bromopropane, 2 bromopropane. This is an example of a position isomers. Okay, isomers sila. Okay? Specifically, position isomers. Kasi magkaiba yung position ng bromo. Yung isa nasa carbon 1, yung another structure nasa carbon 2, yung bromo. I hope that is clear yung position isomerism. Okay, and lastly, let me erase this portion. Ayan. C5H12O, you could obtain here an alcohol. No, molecules of alcohol. Class, do not worry I will not let you draw yun. I will not let you draw structures. Just identify. Example, pinakita. Number 1, ito yung mga structures, set of structures sa number 1. You will just identify if that is a chain, position, metamerism, functional, isomers, ayan. Okay, so you just have to apply your knowledge. What is a chain isomer? What is a position isomer? Okay, so kung titingnan niyo yung set of structures, lahat sila merong alcohol. Alcohol group, OH. Di ba? Merong OH dito sa carbon 1, dito sa carbon 2. Ito naman may OH sa carbon 3. Okay? So you will observe different lang yung position ng functional group alcohol. So this is an example of position isomerism. Okay, or position isomer. Yung isa, 1 pentanol. The second molecule is 2 pentanol. Then the third one is 3 pentanol. Okay? Never mind the naming. Naming ng alcohol kasi hindi pa naman tayo nakapag-discuss ng naming of alcohol. But with regards to alkanes, alkenes, alkynes, you have to expect na pwedeng merong names lang yung ibibigay, no? So just application lang din yan sa mga na-learn nyo sa past discussions natin. Okay, so that is for position isomerism Inyo lang tandaan is nagkakaroon ng differences sa structure because of the differences in the position of the functional group or the position of the substituents. Okay? Now, another Kumbaga, another cases wherein yung position isomer could be observed is pwede itong ma-observed among di-substituted benzene ring. Pakisulat, substituted. Ayan, benzene ring. You are all familiar with benzene ring. Diba? So, ito yung benzene ring with a conjugated pi bonds, okay, inside the cyclic ring. Okay? Kapag sinabing di-substituted, meron siyang dalawang substituent present. Okay? So, we could also observe position isomerism among di-substituted benzene ring. Okay? Kasi pwede nating iba-ibahin yung positions ng dalawang substituent on that benzene ring. So halimbawa, you have a benzene ring with 2 chloro as the substituents. Dalawang chloro ba as substituents or branches of the benzene ring. Okay? Now, when you name this, by the way, when you name this, you consider benzene as the parent already. Okay, kumbaga, when you look for the parent chain, automatic, it's the benzene ring. Okay, so you already have identified the parent, you simply identify now the substituents. Okay, so yung numbering, you have encountered naman cyclic rings, di ba? Yung mga cycloalkanes, cycloalkenes, the same lang yung numbering, alphabetical order. So no worries with this substituents kasi parehas lang naman, chloro. So you could have this carbon with a chloro as carbon 1, then this is carbon 2. So you will have 1, 2 dichloro. Okay, so that is how you name di-substituted benzene. You consider the benzene ring as the parent name itself. Then you simply identify the 2 substituents attached to it. Okay, so that's 1,2-dichlorobenzene. So another positional isomer that you could obtain from dichlorobenzene is a 1,3. This is 1,3 this time. This would be your carbon 1, 2, 3. Okay, so 1,3-dichlorobenzene. And then the last one na position isomer na pwede nyo ma-obtain with dichlorobenzene is a 1,4. Diba? This would be your carbon 1, then 2, 3, then 4. Okay, so you will have 1,4-dichlorobenzene. Sa carbon 1 at saka carbon 4 ng benzene, may naka-attach na chloro. Okay, kaya 1,4-dichlorobenzene. So these are examples of position isomer still. Kasi parehas sila ng formula. Okay, parehas yan sila ng formula kasi meron silang benzene ring, then tigdalawa sila ng chloro. Okay, so you will expect na talagang parehas ito ng formula. Okay? However, magkaiba na yung arrangement ng atoms. Particularly, they differ in the positions of the substituents. Sa unang molecule, magkatabi yung chloro. Sa pangalawang molecule, may 1 carbon apart. Sa pangatlong molecule ng dichlorobenzene, opposite from each other yung position. Diba? So, still an example of position isomerism. Okay? Magkaiba yung position ng substituents. Now, when you encounter di-substituted benzenes, it is a practice sa organic chemistry to use prefixes that indicates the position of these 2 substituents in a benzene ring. I repeat, we have prefixes, okay, that is used to indicate the position of these 2 substituents attached to a benzene ring. So kumbaga, itong mga prefixes na to being listed, applicable lang to kapag di-substituted ang benzene ring. Dalawa lang dapat yung substituent ng benzene ring. Pwedeng parehas, pwedeng magkaiba as long as dalawa yung dalawa lang yung substituent ng benzene ring. That's the time you could use these prefixes that indicates the position of the substituents, okay, in the benzene ring. So kailan natin gagamitin yung ortho? Okay? Class, yung ortho prefix that refers to the two adjacent positions of substituents in a benzene ring. Ibig sabihin ng adjacent magkatabi. Now, basing on the set of molecule structures of dichlorobenzene, saan natin dito magagamit yung ortho prefix? First, second, third. Sabi dito, magagamit to kapag adjacent position yung substitution. Very good. Sa unang molecule, pwede natin yan gamitan ng ortho prefix in replacement of the numbers 1 and 2. So kumbaga, instead of numbers that indicates the position of substituents, you use the prefix ortho. So magiging ortho dichlorobenzene. Kasi ibig sabihin ng ortho, magkatabi yung substituents. Okay? Meta. Kapag naman meta prefix, this refers to the position separated by one carbon atom. Kumbaga, ang dalawang substituents, they are being separated by one carbon atom or one carbon apart. So, on these three sets of molecules, saan natin magagamit yung meta, first, second, third? Okay, very good. Sa second, kasi kung titingnan mo, yung position ng chloro, may carbon apart. One carbon apart. Okay, bago yung kasunod na chloro. So, instead of 1, 3, pwede niyan gamitan ng meta. Meta dichlorobenzene. Okay? And then we also have para. Kapag naman para prefix, this refers to the position of substituents occupying the opposite end. So ito naman yun. Kapag 1,4. 1,4 yung position ng substituents in a benzene ring, then you could use para prefix. So instead of 1,4, you can use para dichlorobenzene or letter P, small letter P. So ako lang klaruhon, class, ha. This ortho meta para prefixes, these are only applicable to di-substituted benzene ring. Make sure benzene ring. Kasi kapag cyclohexane, may dalawang chloro, you cannot use ortho meta para in this case. Kasi it is not a benzene ring. The parent here is cyclohexane, not benzene. Okay, so you have to be careful, okay, when you apply this prefixes, ortho meta para. Another thing, pwede bang gamitin yung ortho meta para kapag magkaiba yung substituents? Pwede. Di ba yung condition lang is as long as di-substituted yung benzene ring, as long as dalawa lang yung substituents in that benzene ring. Kahit magkaiba yan, you can use ortho meta para. So halimbawa, you have here a benzene ring with a methyl and a chloro. Diba? Methyl and a chloro, magkaiba yan. Different substituents. So when you name that, you could use ortho. Kasi magkatabi. Magkatabi yung dalawang substituents. So obviously, you will use ortho. How will you cite the substituents? Alphabetical priority. Which comes first, chloro or methyl? Chloro. Okay, very good. So you will write chloro first, followed by methyl, then the parent is benzene. Nakuha? So ortho, chloromethyl, benzene. Sa isang benzene ring, magkatabi yung chloro tsaka methyl. Yan po yung ibig sabihin ng ortho. Magkatabi yung dalawang substituents. Okay, so position isomers ito. So just to wrap up about position isomers, yung structures nagkakaiba because of the difference in the position of the functional groups or position of the substituents. Okay? Sige. So far, nakadiscuss na tayo ng dalawang common structural isomers, the chain isomers and also the position isomers. Okay, next. The third one, we have functional isomerism. Kapag naman functional isomerism, it occurs when compounds have different functional groups. This time, class, you will also be encountering functional groups. But this time, nagkakaiba yung dalawa or tatlong structure because magkaiba yung functional groups present in that set of structure. Okay, please do not be confused with the positional isomerism kasi kanina, ayan, for a while, let me go back to the positional isomerism. Kanina sa positional isomerism, dapat parehas ng functional group. Only that, yung position ng functional group, magkaiba yung position. Parehas, alcohol, magkaiba lang yung position ng alcohol. Kapag functional isomerism class, you will encounter different functional groups. Halimbawa, ayan, for the first pair of molecules, you will have an alcohol paired with an ether. Diba? This is an ether, CH3, OCH3. Kumbaga, this is ROR. Okay? This one is ROH. Okay? So you will observe same formula, C2H6O, C2H6O, but when you draw the structure, magkaiba yung functional group present. Okay? Kumbaga, dalawang functional group ang pwede nating ma-obtain out of that formula, C2H6O. You could obtain an alcohol or an ether. That's why may nakalagay dito no sa functional isomerism definition, they usually occurs in pairs. So ito yung tandaan nyo kapag functional isomerism. If you encounter pair of molecules, like for instance, alcohol and an ether, most probably those are functional isomers. Kumbaga, ang alcohol will always have an equivalent functional isomer in a form of ether. Kumbaga, kapag naka-obtain ka ng alcohol on that formula, you could also obtain an ether from that formula. Another example, if you have an aldehyde structure obtained from a particular formula, you could also obtain a ketone from that structure. So kumbaga, it occurs in pairs. Yan yung ibig sabihin ng it occurs in pairs. Another example is yung carboxylic acid. Okay, carboxylic acid being obtained in a formula, you can also have an equivalent functional isomer to that, which is in a form of esters. Okay, so yan yung common functional isomerisms. Alcohol ethers, aldehyde ketone, carboxylic acid ester. So halimbawa C2H6O, you could obtain alcohol and an ether. If you try to compare the number of carbon, the number of hydrogen, the number of oxygen, parehas sila. Ito yung magiging formula. You can check that on your notes. Okay, dalawa yung carbon, anim yung hydrogen, isa yung oxygen. Okay, so same formula, magkaiba lang yung structure. Particularly, they differ in structure because they have different functional groups this time. No, magkaiba yung functional groups present in the set of molecules. Next, C3H6O. You could obtain here an aldehyde. So if you have an aldehyde, then you could obtain here an equivalent ketone. Ayan. So you have a propanol and a propanone. Please do not worry sa naming. Okay? Kasi hindi pa natin na-discuss yung naming. Purely identification of isomerism lang muna yung aaralin nyo. Okay? Know how to identify kung functional isomer ba yan. Okay? So kapag nakakita ka isang aldehyde, ketone, then most probably that is functional isomer. But make sure parehas sila ng formula. Kasi kapag example, dinagdagan ko to ng CH3, kumbaga apat na yung carbon dito, dito tatlo, aldehyde and ketone pa din yan, di ba? But when you are asked, are these isomers? Are these isomers? Kapag dinagdagan ko ng CH3 sa left side, yes. No, no. Tama si Angelica Roy. Okay? Hindi na po yan isomers. Kasi this structure already contains 4 number of carbons. Yung isa, tatlo lang yung number of carbons. So yan pa lang, iba na yung number of the carbon atoms in their structures. So not an isomer. Yan yung una nyong titingnan in any set of structures. You have to make sure na parehas yung number of carbon atoms or any type of atoms na makikita sa both structures. Okay? C3H6O2, you could obtain here carboxylic acid. Then yung carboxylic acid, meron siyang equivalent isomer na esters. So, no problem with the functional groups. Ha, you know already what are functional groups, diba? Ito yung carboxylic acid portion, ito yung ester. Okay, RCOO-R, RCOOH. That is carboxylic acid. Okay, and these are other examples of functional isomerism. Let me finish lang yun ha, the structural isomerism. Okay, madali na lang to kasi ito yung pangatlong common common structural isomers. So these are other examples, class, of functional isomerism na you will observe. Parehas, itong tatlong structure, parehas sila, apat yung carbon, 8 yung hydrogen, 1 yung oxygen. But they differ in structure. They differ particularly in the functional group present. Ito, may ether, may alcohol, and this one, merong ketone. C4H6, you could obtain an alkene, or you could obtain here an alkyne. Diba? Magkaiba yung functional group present, but they have the same formula. 4 yung carbon, 6 yung hydrogen. You could check this ha in your notes. No problem man yung formula kasi you just have to count the number of carbons per molecule, the number of hydrogen per molecule. So may oxygen, you also compare ilan yung oxygen per molecule. Okay? So yung point lang dito, class, is magkaiba yung structure nila dahil different yung functional group present. But all in all, they have the same formula. So isomer then, particularly functional isomer. Okay, now for the remaining 3 examples, metamerism, tautomerism, at saka yung ring chain isomerism, these are again rare form of isomerism. So ito yung tandaan nyo, class. Sa metamerism, madali na lang to. Ang metamerism, class, it occurs between ethers. Okay? Ayan. Diba? These are sets of ethers. Ito yung tandaan nyo kapag ethers, ROR. You have a carbon, oxygen, carbon, ROR. Lahat to, tatlong structures na to, they have the same formula, C4H10O. So all of these are ethers. Okay? Now, another structures kung saan pwede natin ma-observe yung metamerism is among, ayan, thioethers. Okay, thioethers. Diba kapag thioethers, yung oxygen is being replaced by thio. being replaced by a sulfur. Ayan. Parehas lang, ni-replace lang ng sulfur atom. So yan yung tandaan nyo kapag set of ethers, parehas ng formula, nag-differ lang yung structure ng mga ethers, metamerism yan. Set of thioethers, okay? Set of structures ng thioethers, magkaiba yung structure ng thioethers but the same yung number of carbons, number of hydrogen, number of sulfur, then that is metamerism. Okay, yan yung tandaan nyo. Ethers, thioethers, or sulfides, sulfides. Okay? Sige. For tautomerism naman, distinct din ito. This occurs between ketone and an enol. Okay? Ketone and enol form. Kapag sinabing enol form, this is an alcohol and an alkene. Okay? So kapag yung structure, same formula, tapos yung being presented na structure is only a ketone and an enol. Enol means a structure with an alcohol, an alcohol and a double bond. Double bond, in. In is for the double bonds, di ba? Alkene. O, kapag yan lang yung being presented na structure, a ketone and then an enol, same yung formula, then that is tautomerism. With regards to the interconversion of ketone to enol or enol to ketone, we will discuss that as we proceed to the reactions happening sa mga alkenes. Madadiscuss natin yan sa alkenes reactivity. For now, just know na tautomerism or tautomers with each other, itong being presented na halimbawa. Kasi you have the same formula of a ketone, then if i-convert mo siya to enol form, same pa din, C3H6O. So yan yung tandaan nyo, ketone, enol to ketone, tautomerism. Diba? So rare lang naman to na type of isomerism. Okay? And then for the last one, ring chain isomerism. Yung ring chain isomerism naman, you have a ring structure, then yung isa naman na structure is an open chain. Okay? I repeat, you have an open chain molecule and yung isa is a cyclic ring. Okay? So yung example dito are alkenes and cycloalkanes. Recall, if you try to scan over your notes on the general formula ng alkenes and also cycloalkanes, they have the same general formula, CnH2n. CnH2n. Okay? So they are isomers kasi same yung formula nila, CnH2n. Only that, magkaiba yung structure. Yung alkenes, open chain. Yung cycloalkanes, naka-cyclic, walang double bonds, di ba? Walang multiple bonds present. Okay, so this is an example. You have an alkene, a propene, and the other one, a cycloalkane equivalent of propene is cyclopropane. Another example, alkynes and cycloalkenes, they have also the same formula. That's why they are isomers with each other. You scan over your notes, ha? General formula ng alkynes, it's CnH2n minus 2. Whereas cycloalkenes, the same din. CnH2n minus 2. So same sila ng formula but different structure. Yung isa may triple bond. Ayan. Halimbawa, pentine. The equivalent cycloalkene of pentine would be cyclopentene. Okay, cyclopentene, di ba? So you have a ring and the other one is an open chain. So yan yung concept ng ring chain isomerism. Magkaiba yung structure nila, obviously, kasi yung isa in a ring form. The other one is in a chain, open chain form. Okay? So please take note of the key or hint nyo. Hint kung saan being observed ang ring chain isomerism. Ring chain isomerism between alkenes, cycloalkanes, alkynes, cycloalkenes. Ang tautomerism between a ketone and an enol. Ang metamerism, ethers, thioethers, sulfides, thiosulfides. Okay? Sige. Do you have any question, class? May questions ba regarding structural isomerism? We're done with structural isomerism. Wala ng tanong. Sige, I will now dismiss you. I'll see you next meeting for another set of lecture discussion. So we will just continue our discussion on isomerism. Okay? Sige, thank you everyone because late na ko sa akong second class. Okay, sige, thank you and I'll see you next meeting. God bless everyone.
Thank you, ma'am.
Okay, thank you. Sige, sige.
Thank you, ma'am.